Hello everyone. Today's topic is module in Verilog, or we can say structure in Verilog, or how a Verilog module or a Verilog programming looks like. Okay. So the first one is the module. This is the basic building blocks in Verilog. It can be a single element or a collection of lower level design blocks, and what it does, it hides internal implementation. Okay, it can be a single element, means in our design either we can have a single module or we can have many modules. So this collection of lower level design blocks means instantiating modules, different modules in our design. Okay, so what is the syntax of writing module? This module syntax: module keyword, then name of the module, then the port list, terminal port list, then semicolon. The semicolon is must. Okay, then what we do, then port declaration we do, then the functionality of the module or the functionality of a design, then end module, and at the end of the end module there is no semicolon. Okay, at the end of the module name there is a semicolon. The starting line there is a semicolon at the end, but at the last line there is no semicolon. Okay, module, this one, and the end module, these are the keyword, these are predefined keyword defined inside the Verilog library. This module represents the design that implements the certain behavioral characteristic. Okay, so what we are doing inside the module is we are implementing the behavior of our design, or we can say that we are writing the behavior of our digital circuit. Okay, inside the module, and all the variable that we use here, so we declare those variable for our design, then the terminal port we declare, and the functionality of the design are defined within module and end module. Okay, this is what I said already here. So inside the module and end module I have the port declaration, then I have the functionality of the design. Okay, and we can include module within module is called module instantiation. Means for example here module and module name, so this end module, inside this one I can have many number of modules. If I want to import other modules for my design, then I can do that one, and that is called, means module inside module is called module instantiation. Okay, so the module instantiation it helps me to reuse a module already designed. Okay, so normally it is helping me to reuse a module that is already designed, or I can instantiate a predefined IP, or we can say that module are nothing but IP. Okay, so example is module, then module name I have given counter, then parenthesis, then semicolon. This end of that there is semicolon, that we have to remember, it is very important. Okay, this semicolon, then end module, then your the design or the functionality. Okay, in between module and end module. Next is the port. Okay, so the modules are connected by the ports. Okay, and what is a port? Port can be your input or your output or the in out. Okay, so suppose this is my for example it is my design, I am designing an AND gate. So this is my AND circuit. Suppose this is my AND gate. So in the AND gate I have two inputs, A and B, and output is Y. Okay, this is my hardware, this is my real hardware. So Y equal to A and B, that is what we know. Okay, so if I want to write a code for this one, so I should have this two port. This is my input port, then this is my output port. Okay, so I have two input A and B, so this is my input port, and I should have one output port to get the result. Okay, y equal to A and B, so y is my output, so here y is my output port. Okay, this is output port and two input port, and this is my design. What I am designing is AND gate. So my module is now this AND gate. Okay, and how I'm going to implement this hardware. This AND gate is module, then module name I have given AND gate, then input, what are the inputs, I have taken A and B, then output is Y. Okay, or I can reverse it also, means I can write first Y, then A, then B. Okay, this will not be a problem, and then semicolon. Okay, then what I have to do, then I have to write the inputs are my A and B. Okay, A and B, so I have used a keyword input. These are the keyword input A, input B. Okay, or I can write like this, input A comma B, then semicolon. I can write like this. Okay, then the next one is the output declaration. This is input declaration, then the next is output declaration. Output port I have to declare, so the keyword I have used output, then here the output is Y, right? So I have given Y output. This is my output port declaration. Then the logic that I have to write, means what the AND gate does. Okay, so it is Y equal to A and B. Okay, so this is the operator that is there in Verilog, and I have already discussed this one during that operator tutorial, that this is the AND gate operator. So if I write Y equal to A and B, then it gives me this result, Y equal to, it will AND A and B. Okay, so I'm using one keyword here, assign, then Y equal to A and B, it gives me result and get output. Okay, this is the AND module. Or in this way I can declare the module, or in this way also I can write module name, then input A, input B, output Y. Okay, so once if I write like this, input A, input B and output Y, then I don't need to write again this one down to this module and module name, that input A, input B and output Y. Once it is declared input A, input B and output Y, either inside the parenthesis or inside this part, in between module and AND module, I don't need to declare it again. Okay, same name not used for different ports. Okay, we should not use the same name for different ports. Like I cannot write, see, I have used a variable A and variable B for input. Okay, and variable Y for output. So here I cannot, already A is declared here, so I cannot write output A. It will show me error. I cannot write output A. Okay, because same name cannot be used for different ports, because already I have taken this a variable A for input port, so I cannot use this one for again output port. Okay, it will show me error. So this is another way to declare this module, input A, input B, output Y. Then directly I can write assign Y equal to A and B, gives result. The both codes are same. Both the code gives same result. Okay, either this way you can declare or either this way you can declare. Okay, next is so why we use these ports, what are the use of these ports. Ports are used to send or receive data from outside world. Okay, so input ports, we are receiving the data. Okay, through input port we are receiving the data. This is, suppose this is a design mode, this is the AND gate. So if I design AND gate like this, so I am receiving the data, the input data from outside world. Okay, then through my output port I am sending the data, through my input port I am receiving the data, and through my output port I am sending the data outside the world. I am receiving from the outside world, I am sending to the outside world. This is using the port. Okay, so I have three type of port. One is input port, one is in-out port, one is output port. So these are the syntax: input, then net type, then range, then input port name. For in out port also, net first one is net type, then range, then input port name. Output is net type, same range and output port name. So this input, this design module receives from outside using its input port. That is what I said here, that through input port we are receiving data from the outside world, and through output design module send data from this port. Okay, so this is, you can see this is my output port. So I'm sending data to the outside world, and this is my input port. So I'm receiving data from the input world. This is my input port, so I'm receiving data from the other module, you can say. And in out is design modules either receives or send data. This is my in out. So this one is receiving, sorry, sending data here, and this is also receiving data, right? This one is, sorry, this one is sending data, and this one is receiving data. So in out is both, so that's why it is written in, both in and out. So in means receiving, out means sending. So it is both receiving, this in out is both receiving and it is sending the data. Okay, all the ports are by default net type OIR. So already I have discussed OIR and range variable. Already I have discussed these two net type OIR and range. So all the ports, if I do not declare anything range or OIR, then by default it is OIR. The Verilog will take by default all the net type as OIR. Okay. This is one example. This is module name. I have given counter. This name you can give any name, counter. Then I have taken the port A, B, C, D, E, F, Y. Input, if I write input A, this is a 1-bit input. Okay. If I write input A, this is a 1-bit input. If I write input 7:0B, then it is a 8-bit input, because this is my input. If I write OIR 7:0B, then we can declare. So this one is a net type of OIR, variable is B. So we can declare again B. Okay. So this is not an error, because by default all the input or output or in out are by default OIR. Okay. So once I have already declared input B, I have already taken this variable. I can again declare. The both statements are same. They are equivalent. Okay, so it won't show any error. If I write output Y, then it is a 1-bit output. 3:E means it is a 4-bit output. So I did not mention anything whether it is a OIR or range. So by default it is a OIR type. If I do not mention anything, then it is by default it is a OIR type. If I write raise 3:0, then it is a 4-bit output variable. Okay, because raise is used for to store data, and E is the variable. So and it is storing 4-bit data. So and this one is accepted edge E is not declared any net type. Okay, see this raise 3:0 E is accepted here because I have not used this variable, because this E variable, as already I said in my previous slide, that once the name is taken, once a variable name is taken, that name cannot be used again. So E variable I have not used here, so I can take that one, I can use that one. So like raise 3:0 E. So okay, that is accepted. Then output raise 7:0, so it means 8-bit output variable. Now the D is initially D was, if I do not declare anything range or OIR, then default is D was OIR. So if I declare range REG, so now D is REG. Okay, OIR 7:0 D illegal, because D is already taken and D is used is range variable, range here REG, so it is illegal as already declared net type. Okay, then in out 7:0 F, so F variable here used as a both input and output. Okay, so then this is the end module, and even I can declare my module like this. Okay, module counter input A inside the parenthesis, then I can give input 3:0 B, then in out 7:0 C, output range 7:0 D, output Y. In this way also I can declare inside the module. So this is this will not be a problem. It is accepted and it is legal one. I can use such kind of coding technique in Verilog also. Okay, it is accepted. And here this one Verilog code I have written here for full adder. Okay, so this full adder has been implemented using all these basic gates, primitives we can say, XOR, 2 XOR, 2 and 1 OR, then AND module. Okay, this is the working code. You can write this code on your simulator and you can implement this one and it will work. Okay, so for today this much only about this structure of Verilog language we can say, or how to write a Verilog coding. So this is the important one, because we should know the structure first, the structure of Verilog coding, and how to write the module and what are the rules, then the variables, how we declare variable, input output variables, and in out, and what do they mean actually, that in out, input and output means. So thank you so much for watching.